Good morning to everyone. Today I discuss the topic of FM generation. Before discuss the FM generation, how FM can be generated. Okay, I already say that there are two types or two method of FM generation. Okay, first is the direct method. The direct method or parameter variation method, and second is the indirect method. The indirect method or Armstrong method Okay, there are two types of method of FM generation. First is the direct method. I already discussed the direct method in previous lecture. Today I discuss the topic on the indirect method or Armstrong method. Okay, so before we discuss the indirect method or Armstrong method, there is a simple topic which is relation between FM and PM. This is the important topic before we discuss the indirect method or Armstrong method. Okay, so what is the relation between FM and PM? Okay, so just we say this is the generation relation between FM and PM. First, generation of FM using PM. Okay, first we consider generation of FM using PM. Means using PM, how FM can be generated. So if we know the generation of FM using PM, then I determine the relation between FM and PM. So first, this is the integrator. Okay, this is the integrator. This is the XT, means message signal. Okay, so output of the integrator is integration of XT. Okay, integration of XT is called the PM signal. Integration of XT is called the PM signal. Okay, so next we use the phase modulator. Because the output of the integrator is PM, means phase modulation. So the phase modulation signal goes to the phase modulator. So modulator has here two types of signal. First is modulating signal and second is carrier signal. This is the carrier signal. Okay, A cos omega ct, and output of the phase modulator is FM signal. Okay, so this is the generation of FM using PM. So if a baseband signal is integrated, then it goes to the phase modulator, and output of the phase modulator is FM signal. So if we consider a message signal is integrated, then PM signal will generate. So next generation of PM. Opposite, generation of PM using FM. Okay, means output is PM using FM. This is the output is FM using PM. Here the output is PM using FM. So here we integrate when FM signal is generated. Okay, but when we generate the PM signal, a differentiator is used, means which derivative the signal. So first here derivative, a differentiator means which derivative the signal. Here xt also a message signal, and this is the derivative from, here the integration, and this is the dxt by dt form, this is the derivative from. Okay, and next it is the FM modulator. Here we use the phase modulator, here we use the FM modulator. Same, this is the carrier signal, because we modulate the signal. There are two types of signal is used, modulating signal and carrier signal. So FM modulator, they are the modulating signal which is derivative from, and this is the carrier signal, same a cos omega ct. After the FM modulator, the output is PM signal. Okay, so FM signal and PM signal is closely related. Okay, FM signal and PM signal is closely related, because in the FM signal frequency is vary but phase is constant. Okay, but in phase modulation the instantaneous phase is changed but frequency is constant. So FM signal and PM signal is very nearly equal to the each other. So this is the relation between FM and PM. And for this, next topic is the Armstrong method or indirect method. Armstrong method. Okay, this next topic is Armstrong method. Okay, why Armstrong method is used? Now there are some disadvantages of direct method. So Armstrong method is used. What are the disadvantages of direct method? Now firstly discuss the disadvantage of direct method. What are the disadvantage of direct method? Why not use the direct method? Because first is the direct method is applicable for low frequency. Okay, direct method is applicable for low frequency firstly, and secondly is varactor diode produce a frequency variation due to harmonic. Okay, varactor diode produces the frequency variation due to harmonic. So FM signal is distorted. Okay, distorted signal. So direct method produce the distorted FM signal, and the frequency is very low. For this reason the Armstrong method is used. So Armstrong method is applicable for high frequency. Okay, high frequency applicable. So here for high frequency, here crystal oscillator is used. For high frequency, we also know that for high frequency generation crystal oscillator is used. Here the Armstrong method is high frequency generation, so a crystal oscillator is used. And here also the working principle of Armstrong method is the utilization of phase modulation technique. Okay, utilization of phase modulation technique. Phase modulation technique, which is phase modulation technique, because phase modulation technique is using the phase modulator, FM signal will generate. Which is the phase modulation technique? Now using phase modulator, PM modulator, Okay, FM signal is generate. So it is called the phase modulation technique, because here phase modulator is used to generate the FM signal. Okay, here also conversion, Armstrong method is also conversion of narrow band FM to wide band FM. There are two types of FM, we already know, wide band FM and narrow band FM. Here the narrow band FM converted into wide band FM. And what is narrow band FM? Now whose modulation index is low is called the narrow band FM, and whose modulation index is large is called the wide band FM. So here also noted that why phase modulation technique is used. Why phase modulation technique is used? Because the phase modulation is easier to generate. Okay, in it also a advantage of Armstrong method is that the generation of FM is easy than the direct method. Okay, the direct method, the FM generation is complex. Okay, so if we use the phase modulation technique, the FM generation is easy, and the FM is wide band FM whose frequency is large. So the beneficial of Armstrong method. So the block diagram of Armstrong method is just as a generation of FM using PM, is the same block diagram of generation of FM using PM. So first the integrator is used. So this is the XT, this is the integrator. Okay, and the output of the integrator is integration of XT. We know integration of XT, we assume integration of XT is called the YT. Okay, so this is the narrow band PM. We consider in PM there are two types of signal. This is the modulating signal which is integrated from, and this is the carrier signal. Here the crystal oscillator is used because high frequency generation, crystal oscillator. Okay, so this is the generation of narrow band FM signal. Okay, narrow band FM signal means the output of the narrow band PM is the narrow band FM. The output of the narrow band PM is narrow band FM. So if we use the phase modulator, integrator is used. If we know the FM modulator, differentiator is used. So here PM modulator, so integrator is used. Okay, if we consider a FM modulator, differentiator is used. Here FM is, here we generation the FM, so PM modulator is used. So first integrate the signal of modulating signal, integrate the modulating signal. So output of the narrow band PM is narrow band FM, but in Armstrong method narrow band FM converted into wide band FM. So next block is frequency multiplier. What is the function of frequency multiplier? Frequency multiplier means multiply the frequency. So if frequency is multiplied, the narrow band FM converted into wide band FM. Okay, this is the wide band FM. Okay, so Armstrong method is convert narrow band FM into wide band FM. Why wide band FM is used? Because the frequency is large, frequency is high, so wide band FM is used. Okay, so if we consider the low frequency, this is the narrow band FM, and there is no frequency multiplier is used. If we used a frequency multiplier, the narrow band FM converted into wideband FM because the multiplication of frequency. Okay, this is the indirect method or Armstrong method of FM generation. Okay.